Welcome to Spring LIB.
For this question, we're asked to suppose that the distance between the slits little d is the same as the distance between the slit to the screen big D for a single slit or double slit. So the two slits merge into one cell slit of width 2d. Show that equation 9 reduces to the correct equation for a single slit diffraction. So I wrote down the phase shift for the single and the double, delta and beta here, relative to the distance between the slit little d, or the distance between the two slits. Oh, actually, I wrote these backwards. Funny enough, this is actually the single. Sorry about that. So, and you can tell because it uses the big D, which is the distance between the single slit and the screen, and little d is the distance between the two slits. So this would be the double. Okay, so now we're going to use that information to reduce this down. Well, if little d is equal to big D in these expressions, then that means that delta is equal to beta. Well, the equation for intensity, I, is equal to I naught times the sine of beta over 2 divided by beta over 2. And this is all squared. And then it gets multiplied by the cosine of delta over 2 squared. But we can replace beta with delta. So this becomes I naught times, you have the sine of beta over 2 and the cosine of beta over 2 that are both squared. So we'll move both of those into the parentheses. So this is sine beta over 2 times cosine beta over 2, all divided by beta over 2 squared. Well, we can simplify this even more because the sine of an angle times the cosine of an angle is the same as the sine of that angle, all divided by 2. So if we simplify that using this, we have I naught times, we have the sine of beta. Now, so it would be the sine of beta divided by 2, because the cosine of an angle times the sine of an angle is 2 times sine of 2 times that angle divided by 2. So the sine of beta over 2 times the cosine of beta over 2 is equal to the sine of beta all divided by 2. So this would be the sine of beta all divided by 2, and then this gets multiplied by beta over 2. You still have that on the bottom. This is all squared. Obviously, those two cancel, and the 2's cancel, and you have I naught times the sine of beta divided by beta, and then all these values get squared. Okay, so we have our expression there, but let's go ahead and do a change of terms. So we're going to let beta equal beta prime over 2. So we can say that beta is equal to beta prime over 2, right? Or in other words, so we can plug that back into our expression, but in other words, beta prime is equal to 2 times beta. Okay, well, if we, again, if you plug beta, or beta equals beta prime over 2 back into our expression here, so if you let beta equal beta prime over 2, you get back to our equation of the intensity for a single slit with a phase change of beta prime equals 2 beta, right? So that it would be the exact same as a single slit diffraction, or a single slit intensity, excuse me. So when beta prime equals 2 beta, we can go back to our expression for beta for the single slit, which is here, and do a change of variables. And we can do that for beta prime. So what we have here is beta prime, which is equal to 2 times beta. So we'll just say this is equal to 2 times, well, what was beta? We said that beta was equal to 2 pi times d times the sine of the angle theta divided by lambda. Well, you could also say that this is equal to 2 pi times 2d, so I just distributed that 2 through, times the sine of the angle theta divided by lambda. So therefore, this is the same as a single slit. So we can say, thus, this is the same as a single slit with a width of 2 times d. So we just went ahead and proved it, and there is our proof. We can box all of this in as the solution to our question.